everyone, welcome back to the Science Behind Papers channel. Here are Sydney and Ella. In today's video, we're going to explore climate change. What are the causes, its effects, and what we human beings can do to improve the situation. We will summarize the key points from People in Need and analyze the science behind climate problems. Part 1. Summary of the article. The structure of the article includes the conceptual understanding of climate change, the causes, and the current situation, as well as the need for a solution. Firstly, understand climate change. It refers to the long-term alternation in global weather patterns and climate systems, mainly driven by human activities. This change has led to a global temperature rise, frequent extreme weather, and the destruction of ecosystems. In terms of understanding the definitions, we need to clearly distinguish between climate and the weather. Although the two are closely related, weather refers to the short-term conditions that can change rapidly, while climate determines the long-term characteristic of a specific location. Climate determines temperatures, weather diversity, the trace of winters, rainfall totals, and the nature phenomena such as severity of storms. It is because of the delicate relationship that we are facing both temperature rises and more frequent weather extremes, as well as natural disasters as a result of climate change. The fundamental causes of climate change lies in the fact that the Earth is a greenhouse. Solar energy reaches the Earth in the form of radiation, and 2/3 of it is absorbed by the Earth's surface. Solar radiation warms Earth, but greenhouse gases like CO2 and methane trap heat, maintaining habitable temperatures. Human activities such as burning fossil fuels, deforestation, increase GHG concentrations, enhancing the greenhouse effect and causing global warming. So, what is the problem of climate change that we are facing now? The Earth has warmed by approximately 1.1 degrees since the 19th century. A new United Nations report discussed the different consequences of warming by 1.5 degrees or 2 degrees. You may think that half of a degree may not sound that much, but we must remember that generally speaking, every tenth of a degree has a huge impact and difference on the quality of human life. Moreover, we have exposed obvious international imbalances in dealing with climate issues. Many developed countries that bear the greatest responsibility for greenhouse gas emissions are less affected by climate change. However, developing countries with poor adaptability to climate change are more severely affected. Part 2. Article analyze an in-depth understanding. The physical nature of climate change, including energy balance and the greenhouse effect. The temperature of the Earth is determined by the balance between the input of solar radiation and the output of infrared radiation on the surface. According to the Stefan-Boltzmann's law, when the greenhouse effect is ignored, the theoretical calculated average temperature of the Earth is only minus 19.5 degrees, which is much lower than the actual observed 14 degrees. This difference directly proves the key role of greenhouse gases. Some gas molecules in the atmosphere absorb infrared light, but does not absorb visible light, which behave as glass of a greenhouse. Water is a major greenhouse gas, and carbon dioxide is the second most prevalent, followed by methane. They absorb infrared light emitted from the Earth's ground and are excited. The excited molecules then emit same infrared light to all directions. If relying solely on the solar radiation model without the greenhouse effect, the Earth could be as extreme as the moon, and life would not be able to survive. The greenhouse effect itself is a necessary condition for maintaining livability, but excessive human activities have enhanced this effect. The combustion of fossil fuels and deforestation not only generate a considerable amount of carbon dioxide, but also diminish the capacity of nature to absorb and process it. Ultimately, this intensifies the greenhouse effect. The rise in the temperature will also lead to greater water evaporation, exacerbating climate change. So what should we do to solve this problem? Climate change is essentially a problem of imbalance in physical systems, and solving this crisis requires us to strictly follow the scientific laws of energy conservation, thermodynamics, and molecular interactions. The core of emission reduction is to weaken the greenhouse effect at the molecular level. Greenhouse gases such as CO2 and CH4 cause an imbalance in the Earth's energy budget by absorbing infrared radiation of specific wavelengths. Therefore, the essence of emission reduction is to decrease the number of molecules in the atmosphere that can absorb the infrared rays. We can replace fossil fuels with zero-carbon energy sources, such as solar and wind power, to fundamentally eliminate the release of CO2 during combustion. Moreover, in order to control methane, it is necessary to specifically target major emission sources, such as animal husbandry and oil and gas leaks, as the greenhouse effect of methane is 30 times that of CO2. We can also implement adaptation strategies to build resilience under thermodynamic management. For instance, in terms of urban heat island mitigation, laying high albedo materials such as light-colored pavements can reflect solar radiation back into space. Now we are moving to the end of today's content. We have one final advocacy that we would like to convey to all physics enthusiasts. Climate change is a real classroom of Stefan Boltzmann's law. Every joule of heat and every degree of temperature rise write down the future of humanity in the laws of physics. Whether we abide by these laws determine the fate of the Earth. Thank you for watching. We welcome your questions.